Hi everyone. In today's lesson, we are going to calculate the specific heat capacity of water using a calorimeter. So first, some background theory. A calorimeter is a device used to measure how much energy is required to heat up a substance by a certain amount of temperature. Now usually the substance is going to be liquid, so it can be water or alcohol or oil. If you remember what we used in class, this is a calorimeter. It's got a coil inside to heat up the water. It's also got a place for the thermometer in order to measure the temperature. Now, some physics fun fact. You probably have seen the word calorie before, or perhaps you've heard of it. One place you can find the word calorie is on a package of food. Perhaps a chocolate bar or a can of soft drink. Okay, and that tells you how much energy there is in your food and your drink. Now there are two types of calorie. So the first one is what we call a small calorie. So one small calorie, so the word cal with small c, is how much energy needed to raise the temperature of 1 gram of water by 1 degree Celsius at a pressure of 1 atmosphere. Now, the term 1 atmosphere is basically just the atmosphere, the normal atmosphere in our house or the lab. The second type of calorie is what we call a big calorie. So, cal with the big C. Now, this one is also known as food calorie. Okay, and this is the one that you find on your food packaging. Now, 1 food calorie is 1,000 small calories. So, to put that into perspective, if you've got a bar of chocolate and it says that there are 47 big calories inside it, that means that you've got enough energy to heat up 1 gram of water by 47,000 degrees Celsius. Yes, that is a lot of energy. Now, what's happening in the calorimeter is we're using electricity. So electricity is supplied through the calorimeter to heat up the substance. In our case, that's going to be water. So if we know the voltage and the current and how long we leave the calorimeter on, we can work out the amount of heat energy we apply. The equation we're going to use is energy is equal to voltage multiply current multiply time. In symbol form, it's going to be Q equal to V multiplied by I multiplied by T. Now, this heat energy is used to heat up a known amount of water. The temperature rise is measured, and then we can calculate the specific heat capacity by using this equation here. Energy equal to mass multiplied by specific heat capacity multiplied by change in temperature. Using symbols, that's going to be Q equal to M multiplied C multiplied by delta T. And we're going to rearrange the equation, and we're going to get C is equal to Q divided by M multiplied by delta T. Okay, now some of you may wonder, how do I get C equal to Q divided by M multiplied by delta T? So what we're doing is we want C by itself. Now C is multiplied by M and then multiplied by delta T. And in order to get rid of M and delta T, we are going to divide M and divide delta T. or you probably have heard of the move it to the other side method. And again, it's going to work the same way. Okay, so when you move m and delta t to the other side, the multiplication is going to become division. So now we have q divided by m times delta t. Now let's try a question. A student wanted to measure the specific heat capacity of water by heating 100 ml of water in a calorimeter. She used an average current of 1.55 amps and a voltage of 3.6 volts. After 5 minutes on the stopwatch, the temperature was observed to increase by 4 degrees Celsius. Calculate the specific heat capacity of water. So, the first thing we need to do is we need to underline all the key information. So the first one is going to be 100 ml of water. Second one is 1.55 amps for current and 3.60 volt voltage. 5 minutes for time and 4 degrees Celsius for the change in temperature. Okay, in order to solve this problem, first we need to convert to SI unit. So basically, we've got 100 ml of water. That's going to be 100 grams. Now the thing is, remember in physics, mass has to be in kilogram. So 100 grams is going to become 0.1 kilogram. We've also got time being 5 minutes. In physics, again, we are going to use seconds. So 5 minutes is equal to 300 seconds. The second step, we need to calculate the amount of energy used. So remember the equation Q equal to V times I times T. So the heat energy Q is equal to 3.6 volts multiplied by 1.55 amps multiplied by 300 seconds. And that's going to give you heat energy equal to 1,674 joules. The third step is we're going to try and calculate the specific heat capacity. So the equation we're using is Q equal to M multiplied by C multiplied by delta T. So remember, rearranging it, we have C equal to Q divided by M multiplied by delta T. Okay, put everything into the equation. Q, the heat energy, is 1,674. M is 0.1, and delta T, change in temperature, is 4. Okay, put everything in the calculator. When you put it on the calculator, make sure that you use brackets, okay? Because if you don't use brackets, that's going to give you a completely different answer. Okay, now the thing is, because the 0.1 multiplied by 4 is down at the bottom, we're going to put them inside the brackets. So when you put it in the calculator, it's going to be 1,674 divided by brackets 0.1 multiplied by 4 close brackets. Okay, or you can use this symbol here on your calculator, and what you're going to get is the specific heat capacity of water is equal to 4,185 joules per kilogram per Kelvin. Okay, so this student's got quite a close result to the actual specific heat capacity of water. Now, just to summarize what we've done. Okay, so in order to solve this kind of problem, you need to first convert to SI units. Okay, so mass, you need to have it in kilogram, and time, you need to have it in seconds. The second thing we need to do is calculate the amount of energy used. We're going to use the equation Q equal to V multiplied by I multiplied by T. Okay, so V is for voltage, I is for current, and T is for time. To calculate the specific heat capacity, we're going to use the equation Q equal to M multiplied by C multiplied by delta T. M is the mass, C is specific heat capacity, and delta T is the change in temperature. Rearrange it, and you're going to have Q divided by M multiplied by delta T. So whatever heat energy you get from the first equation there, V times I times T, you then put it into the last equation. And you also put the mass in and the change in temperature, and you should get the specific heat capacity of water. So I hope this one helps you with this type of problem.